Listen very carefully. The first one is continuous X-ray spectra. See, this is a nucleus. So inside like a taken as positive charge. First cell, K cell. Let us consider any one of the material. So first K cell, it consists of 2 electron. L cell, that is 8 electrons. The next one, generally depending upon the material, suppose you are assuming only when you are book having only 6, so we can also take like a 6. If you are assuming one material only, so when a fast moving electron is coming, so it is a one fastest electron. This electron is strike to the metal, that is target nucleus. So that time interaction between this nucleus and this electron, that time these electrons either accelerate or deaccelerate. That means initially it is accelerate very come fastly because of fastest electron. That time they having large kinetic energy. When it hit into the target, that time they losing the kinetic energy, that is changing the path also because of interaction between nucleus and the electron. So it lost the kinetic energy and the change in the path also now going. That time they are releasing large amount of kinetic energy. This kinetic energy is equal to that is producing to the continuous X-ray. It is a very important. The losing the kinetic energy is releasing like obtained in continuous X-ray spectra. That is, this radiation is producing from such deaccelerating electron is called braking radiation. Define braking radiation, that is the radiation is producing such deaccelerating electron is called braking radiation or Bremsstrahlung radiation. That is not needed, that is braking radiation. See, in continuous X-ray spectra, that is braking radiation, that time the energy of the photon is emitting is equal to the loss of kinetic energy. That means, see, when you apply the high potential difference between the cathode and anode, so that high potential difference, that is electron volt, that is equal to the energy of each photon, that is E. When an electron gives up all its energy, the photon is emitting with the highest frequency, that is the initial kinetic energy of electron is equal to the accelerating voltage. So the initial kinetic energy, that is energy of each photon E, is equal to the accelerating voltage, that is EV. So according to Planck theory, energy of each photon is E equal to h nu, that is h nu. Here putting h nu naught because of the after hitting the target they are losing the frequency, that is losing the kinetic energy, even frequency also low only. So put no nu naught, that is cutoff frequency, that is the minimum frequency last obtained. So h nu naught is equal to EV. Then the value of nu naught, nu is equal to C by lambda, even nu 0 equal to C by lambda 0 because of lambda 0 also cutoff wavelength. This is cutoff frequency, this is cutoff wavelength. So instead of nu naught, replacing h, C divided by lambda naught is equal to EV. Lambda naught is equal to hc by this down EV, where lambda 0 is cutoff wavelength. See, very important, after substituting h value, that is Planck constant, C velocity of light, E energy of, that is a charge of electron, V potential, applying potential. So after substituting the constant value, we get lambda naught is equal to, after substituting we get 12,400 divided by applying volt V into, that is unit of wavelength, that is Armstrong. Okay. This relation is give to the Duhan formula, that is Duhan formula. Suppose they will asking derive Duhan formula, or last time I think midterm test is the 2 more question asking just define Duhan formula. The question is asking means you just write when the electrons initially gives up the electron, that is total potential difference EV is equal to the electrons is losing the kinetic energy, that is energy of each photon, both are equal, E equal to EV. Then substituting we get lambda naught is equal to 12,400 divided by V. That formula is known as Duhan formula. This Duhan formula is depending upon the accelerating potential. Because of lambda naught is inversely proportional to V, that means lambda naught is increases, V is decreases. Dear students, the next one is characteristics X-ray spectra. Generally, you know, it consists of a definite, well-defined wavelength is superimposing on the continuous spectrum. That time is producing like a characteristics X-ray spectrum, that is like that. Number of peaks are there. This is a well-defined wavelength. So this type is called like a characteristics X-ray spectrum. That is, see, suppose when the fast moving electron, see, the 2 electrons are there, this nucleus, 2 electrons are there, is 8 are there. See, when the fast moving electron is knock off 1 electron from K cell, so this place is vacancy is there. This vacancy is filled by nearby the 1 electron from the L cell. So here this electron is filled with this K cell. So for a energy level diagram, if you draw, means this is K cell, this is L cell, this is M cell, and so on. Suppose this K cell is, if the vacant is there, means this K cell, suppose L irukkalam, that is L and வந்து fill பண்ணலாம், even M லையும் வந்து fill பண்ணலாம், and so on. During this transition, the energy difference is radiated in the form of X-rays of very small wavelength. This is correspond to, we can say K alpha, this is taken K beta, and so on. Suppose L means filled with like that, that is L alpha, L beta, and so on. So this type of spectra is known as characteristics X-ray spectra. Dear students, it's a very important topic. In this, today we taught, that is what are the properties of X-ray, how the X-rays are producing, what are the different types of X-rays, and next one remaining one small topic is pending, that is application of X-ray.